That fix everything? Can you people see me now? Hopefully you can see me now. I'm assuming you can see me now. I forgot to hit the go live button because I'm a fucking mook and this is my first time doing it. So hopefully hitting the go live button fixed the problem. I'm assuming that it did. I have to wait for the feedback. And naturally there's going to be a little bit of a delay. Since there's going to be a little bit of a delay, I'm probably not going to know right off the bat if that fixed it. But I do believe it did. So, I don't know if you guys could hear me prior and just not see me, or if you could neither see nor hear me. Okay, James Downer said, yep, everything's good, awesome. So, this past Wednesday, and I'm sorry if I'm repeating myself if you guys were capable of hearing me but not seeing me. This past Wednesday, Dr. Jason Lisle, who is a Ph.D. astrophysicist and a creationist, make it make sense because I don't get it, was on Standing for Truth's channel talking about how not just the Earth, but the entire universe, 6,000 years old. That's an eyebrow raiser because that makes no sense to me. So we're going to be reviewing that video. We're going to be doing it point by point. I can't promise that the stream is going to be super long. I'd like to get through the whole video, but I have an old MacBook here, and sometimes when I'm running OBS, it gets a little hot, and I do have it plugged in to the charger, which doesn't help, except that it does help with the draining of the battery, because OBS is, I'm sure, notorious for draining batteries. I've heard that from a lot of people. So, let me get the video set up here, and then what we can do, get going. I believe, yep, let me just, sure everything's working the way that I want it. There we go. I just need to shrink myself down a wee there. I'm gonna go Vosh style tonight, down in the bottom right corner. Hopefully it doesn't make anybody angry. Hopefully nobody calls me a copycat. So yeah, the sound, I did a sound check, so the sound should be good. If it's not, let me know. When it first starts off, it might sound a little bit muffled because Standing's mic was a little muffled at the beginning of the stream, so that might be, so give it about, a couple minutes and then tell me how the audio is, because I know when they started there was a little bit of muffling going on. So let's go ahead and dive right in, shall we?
Hey guys, looks like we are live today. We've got a very special guest, Dr. Jason Lisle. Dr. Lisle, thank you for giving us your time today. It's very important show.
My pleasure.
Dr. Lisle, you have been a tremendous blessing to not only up here at the Standing for Truth Creation Ministry, and not only to our faithful listeners and supporters, but also to countless Christians around the world with your dedication and defense of the faith. God bless you for that, Dr. Lisle.
Well, thank you. I appreciate it.
No problem. As a matter of fact, I wanted to point out your book, Ultimate Proof of Creation, was one of the first books I have ever personally read as a young Earth creationist. And it was actually my wife's first book. Not one of her first books on the topic, but literally her first book. And I know this because it was me who recommended it to her at the time and let her borrow it. So you've been a blessing.
And I want to
point out that Dr. Lisle has written many other must-read books as well, most of which I personally own. A few of those I'm going to put on screen too for people to see. Taking Back Astronomy.
Okay, I do want to pause right here, because my first question is, taking astronomy back from whom, might I ask? Who took astronomy from us anyway? I don't, maybe it's just a hyperbolic title, and I just don't realize it because I've never read the book, because I don't read shit that creationists write. But who are you taking this back from? Who are you taking this back from? All right, let's continue.
Understanding Genesis, how to analyze, interpret, and defend Scripture, and Discerning Truth. So guys, check those out. We're going to make sure that the links to those books are in the description box. For now, I'm going to hand it over to Matt and give a brief introduction to Dr. Lisle, which Dr. Lisle can then expand upon if you would like to. Matt, the floor is yours.
All right. Well, thanks again for being here, Dr. Lisle. Correct me if I'm wrong on any of this, but Dr. Lisle, you graduated from summa cum laude from Ohio Wesleyan University, where you double majored in physics and astronomy and minored in mathematics. He also graduated, worked at the University of Colorado, where he earned his master's degree and PhD in astrophysics. While there, Dr. Lisle used SOHO spacecraft to investigate motions of the surface of the sun while looking at solar magnetism and subsurface weather. His thesis was entitled Probing the Dynamics of Solar Supergranulation and its Interactions with Magnetism. He has also authored a number of papers in both secular and creation literature. So I hope I got all that good. And yep. Okay, awesome. Not sure how long we have you today, so why don't we just jump right into the discussion?
Okay.
Okay, great. Before we get into the science, though, that confirms biblical creation, I think the best question to start off this entire interview with would be: is Genesis 1 through 11 actual history?
Yeah, it better be.
I like how he says it better be, but the thing is, it's not. Very, very, very little of the Bible is considered actual history. There's very little historicity in the Bible, but that's not really what we're getting into here. So let's continue, shall we?
The other books of the Bible refer to it as literal history. Jesus Christ is descended from Adam. You can read the genealogies there in Matthew and in Luke, and I think it's the one in Luke that goes.
You know what? I just realized something. I'm going to move myself over to here because my watermark is in the way. Because I'm an idiot and didn't realize that to begin with. Hey, it's my first time. What are you going to do, right? All right. Now we can continue.
All the way back to Adam. So yeah, it's real history. The way it's written too, it makes frequent use of what's called the verb consecutive, and that's where you have and this happened, and that happened, and that happened. It sounds kind of weird in English, but and followed by a verb in the original Hebrew word order. When you have a sequence of that, that's always indicative of literal history. So there's no doubt, and frankly, Genesis 2:4, where it says, these are the generations of heaven and earth. These are the birthings or the origins of heaven and earth. It's telling you that this is history. This is how the universe began, and how it came to be the way it is today. So creation, the flood that occurred at the time of Noah. Peter alludes back to that as real history. It's something that happened, and it foreshadows the coming judgment by fire. So of course, yeah, it's all real history.
And like I said, literally none of this is history. We can't verify any of this. I'm sure a lot of you might be cringing, but we're not here to talk about the historicity of the Bible. So that's why I'm letting this part just run through. I'd like to address it, but that's not the substance of this particular stream.
And it's theologically important that it's real history because it's in Genesis where we learn that death's the penalty for sin. Death came into the world as a result of Adam's sin. And if that's not real history, then why did Jesus have to die on the cross? So you see the gospel message, and it goes back to the literal history of Genesis.
What?
Awesome. Great answer, Dr. Lisle. I just wanted to point out a couple super chats that came in. Modern day debate. Thanks for coming on, Dr. Lisle. Really cool. So everybody's excited. Great answer, Dr. Lisle. My next question would be, and it's an exciting one, and I believe will lead into some solid follow-up questions and discussions. What would you say are some of the best lines of evidence against an old universe and for a young one, Dr. Lisle?
The best ones we have in the birth certificate of the universe. The Bible is a history book that records.
I'm sorry. Birth certificate of the universe. He says it's the Bible. If there was a birth certificate to the universe, and this is a big if, because we something I want to clarify really quickly is you'll often hear people say the universe is 13.8 billion years old. That's actually not the right way to word it. I'm not going to say that's not true. It's just not the right way to word it. The furthest back we can go currently is 13.8 billion years. There could be another billion years before that. There could be another 100 years before that. We don't know because there's a point past which none of our physics works. So the most accurate way to word it is that the furthest back we can go in the history of the universe is 13.8 billion years. That aside, if the universe, again, big if the universe did have a birth certificate, that would be the cosmic microwave background. But we'll get into that later in the video.
When the universe began, in the beginning, God created the heaven and the earth. Human beings are made on the sixth day, and from adding up those genealogies and so-and-so to get so-and-so, you find that's about 4,000 years between Adam and Christ's earthly ministry, which was about 2,000 years ago, so something like 6,000 years. That's the best evidence because it's recorded history. Now, I think there are lines of scientific evidence that confirm that history that confirm a recent time scale. But that's the best because it's history, right? I mean, if you want to find out when the last World War happened, you read a history book. You don't do a science experiment, mix chemicals. It might confirm that, but the best way to answer it.
By the way, a lot of people in history actually do conduct certain experiments to determine certain aspects of history or whether or not they're viable aspects of history. But let's continue.
History question is with a history book. That being said, I think there are a lot of lines of evidence that confirm that. Lots of stuff in space, that's, of course, my area of expertise. There are things that can't last billions of years. Comets, for example, they can't last even millions of years, really.
Hold on, what? Okay, so notice how he goes to comets. But what about stars, which last billions of years, like the sun, which has been burning for 4.6 billion years? What about planets, like the Earth, which has existed for 4.54 billion years? What about black holes, white dwarfs, neutron stars, galaxies? I mean, for Christ's sake, the Milky Way galaxy is, 13.2 billion years old? It's one of the oldest galaxies we know of, actually. So I liked how he immediately went to the one thing that we know doesn't last very long, but ignored all of the things that we know do. And see, I'd like to pose a question to you guys. And you can feel free to answer it in the live chat, answer it in the comments after this stream is done. But the question is, Dr. Jason Lisle here is a Ph.D. astrophysicist. I believe Matt said that he received his degree from the University of Colorado at Boulder. Do you think that he actually knows the shit that he's saying is just fucking wrong and he's lying about it? Or do you think that he's just that incompetent in his field? I know which one it is for me. I know which one I think it is because I've seen this video a couple times, actually. But I want you guys to ponder that question and then let me know what you think.
Comet is made up of ice and dirt, and it orbits the sun in an elliptical path, and when it comes close to the sun, that icy material is blasted out into space. That's what forms the comet's tail. We had a really nice one this last summer, actually. I hope you got to see it. Nice naked eye comet. It was very beautiful. But every time you see a comet, it's getting smaller. It's losing mass. We can calculate the amount of material that's there. We can calculate the rate at which it's being depleted. They can't last millions of years. 100,000 years maximum for a typical comet. In fact, in my doctoral research, I used the SOHO spacecraft, and it looks right at the sun. And one of the instruments on it blocks the sun and looks at things that get real close to the sun, like comets. And I've seen comets that have gone behind the sun and been totally destroyed in one pass. So they don't last millions of years. And my secular colleagues don't even dispute that.
I did also want to point out that he's not entirely wrong here. A lot of comets will be essentially disintegrated by the sun with the extreme amounts of electromagnetic radiation that essentially cook it away. That is what produces the comet's tail, as he stated. But there are a lot of comets that don't get as close to the sun and so can actually last hundreds of thousands. I do believe that there are actually some that can last millions of years, but in terms of billions of years, like with a B, I don't know if we have any data that comets can last that long other than the ones that aren't actually orbiting a star. Or if they do, they don't get anywhere near close enough to it. But like I said, I honestly don't actually know if we have enough data on that. But let's continue, shall we?
And they would say that there must be some kind of source of new comets. They call it an Oort cloud. There's no evidence for that in our solar system. In terms of
that is false, actually. The simulations we have run on the formation of our solar system, as well as the gravity of our solar system, thoroughly indicates that there is an Oort cloud. We haven't directly observationally verified the Oort cloud, but we know that there are comets whose periods, or the time it takes to go from a point in the orbit to that same point, are longer than those of Pluto. And Pluto is, as we all know, the most distant. Well, it's not really a planet, it's more of a dwarf planet. It's the most distant major object, let's say. There are other objects, much smaller than Pluto, with much longer periods. Where are they originating from? It's either from outside of the solar system, in which case they shouldn't be recurring, as I think a small amount of them are, or it's that there is a huge cloud, so to speak, of comets and asteroids outside of the orbit of Pluto that they're coming from, and that would be the Oort cloud. So while he would be correct if he were to say that we haven't observationally verified the Oort cloud, there is evidence that it exists from our simulations, from the periods of certain comets. I believe that we've also observed similar types of structures in other solar systems. So there is evidence for it. So he's just wrong here.
Observational evidence. Lots of things like that. The rate at which magnetic fields decay. magnetic fields don't last millions of years. Magnetic fields are caused by electrical current in the core of a planet like the Earth, and that has been decaying. We know Earth's magnetic field's been decaying. We've been able to measure it for the last almost 2 centuries.
That's not true. Earth's magnetic field has fluctuated, but it hasn't been decaying. And I did talk to somebody who said if Earth's magnetic field, the strength of it rather, has been decaying, it has been so non-significant that it isn't even worth discussing. The reason for this is that Earth's magnetic field is at least currently, continually sustained magnetic field due to what is called the magneto-hydrodynamic effects occurring in the molten ionized iron nickel core. That core is kind of sloshing around, and it's very, very hot to the point that it's ionized. And if you take an electric charge and you move it, you generate an electric current. And if you have an electric current, you can have a magnetic field. I know this very well because I've worked in ferrous metals foundries, and the way that induction furnaces work is by creating a powerful electric current and then oscillating it like this, which creates a magnetic field and then oscillates that magnetic field. And what that does is it creates microscopic electric currents homogeneously within the metal inside of what's called the crucible of the furnace, called eddy currents, and those homogeneously heat up and melt the metal. So we do know that electricity can generate a magnetic field, and we do know that there is electricity in Earth's core. That is where Earth's magnetic field comes from. To say that Earth's magnetic field is decaying, especially as a PhD astrophysicist, is just woefully disingenuous or as equally dishonest. But I'll let you guys decide which one you think it is.
It's definitely decaying. It seems to be an exponential decay, which is what we would expect on first principles. It's not oscillating, not today anyway. It might have during the flood, but other planets as well. There's evidence that Mercury's magnetic field's decaying. Jupiter has an enormous magnetic field. They don't last millions of years. With Earth's magnetic field, based on the current rate of exponential decay,
I did want to point out that Earth's magnetic field has already lasted billions of years. 4.5 billion years, to be exact.
Run it back 60,000 years ago, it would have been stronger than a neutron star, which is enough to rip the atoms of your body apart.
No. See, he's talking as if Earth's magnetic field started with some base level of strength and then has slowly been going down, and in order for it to be at the strength that we observe today, it would have had to been astronomically more powerful than it is today, which isn't true. Like I said earlier, Earth's magnetic field is roughly constant. It's been about the same. There's been fluctuations in it. This dude has a PhD. There's no way he doesn't know these things. There's just no way.
So it can't be anywhere near that old. It's not even a million years. It can't be anywhere near that old. For carbon dating, a lot of times people think carbon dating gives the millions of years. It doesn't. No, it's
true.
You know, all these dating methods are based on certain assumptions, but the fact is, a lot of them give ages. Even if you assume secular principles of uniformitarianism and naturalism, a lot of them still give ages much less than the billions of years, including the fact that C14 has been found in things like diamonds that are buried deep down in layers of the Earth that are well insulated from cosmic rays. C14 doesn't last even a million years.
I did want to point out really quickly, he is correct here. I think carbon dating only goes to roughly about 50,000 years, is about as far back as you can go with that. But somebody who has degrees in geophysics, many of you may know him, Orge 373, I think it is. I might be wrong on the numbers. 313, is it? Something like that. He said he did research on this whole carbon-14 and diamonds and being shielded, and he said, I can't say that it's wrong, but I can't say that it's right, because he stated that he didn't find anything to either confirm or deny that. So I just wanted to point that out really quickly.
Very quickly, and so the fact that you find it in fossils and in just about everything that has carbon in it is a strong indication that the Earth is not anywhere near billions of years old. Lots of stuff like that.
Wow, that's a great response. A lot of good information there. Dr. Lisle, with the comets one, for example, that limits the age of the universe, I've seen, as you pointed out, this Oort cloud that's constantly being invoked. But like you said, this Oort cloud is not actually based on real, observable, and empirical evidence. Is that right, Dr. Lisle?
Yeah, I mean, it's the idea is with an Oort cloud that it's named after Jan Oort, the guy who came up with the idea. The idea is that there's a vast supply of potential comets out beyond the farthest planets, out way beyond Neptune, but we couldn't possibly detect them at that distance. There's no way to detect them. So it really seems to be a rescuing device, a hypothesis that the secularists have invoked to protect their worldview from what appears to be evidence to the contrary. And they'll say, "What you can't
Wait, what evidence to the contrary? You would probably be one of a very, 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 very extremely few amount of astrophysicists, professional astrophysicists, that would deny the existence of the Oort cloud. There are a lot of things that we can't actually observationally detect, but we still know they're there. A lot of elementary particles would be a good example. Some people might be able to say, well, we do kind of observe them. There are ways of observing something where you're not technically observing it. You're just observing the remnants from it, like we do with particle collisions. That's how we found the Higgs boson. We looked at particle collisions. We looked at what was left over. We put all those fragments, so to speak, back together, and we're capable of saying, hey, this is what we have. So there's a lot of things that we know we can't really observationally verify, but we can still thoroughly verify them. Like I said, that the Oort cloud, it is technically considered hypothetical, but like many other hypotheses out there, there isn't any reason why it should be false. And we are expected to, I believe with the James Webb Telescope, which is supposed to be launched anywhere between 2021 and 2024, I can't remember the exact year because they keep pushing it back, we are supposed to get with that telescope observational evidence of the Oort cloud.
disprove an Oort cloud, and that's true, I can't. It's undetectable. But there's no evidence for it either.
Really quickly, it's not that it's undetectable, we just haven't detected it yet. It is detectable, we just don't have the methods to do it quite yet.
Say, well, we find evidence of Oort clouds in other solar systems. Not really. We do find solar systems that have some kind of debris orbiting them, but we don't know that it's billions or trillions of comet nuclei. And even if you did find an Oort cloud,
so then what is it?
And how would you make it under natural?
I mean, if it's not a bunch of comets and what have you, what is it? Is it a bunch of fairies flying around? Are there like hundreds of thousands of planets in this solar system? Like, what would it be? Do you have an answer for that, Dr. Lisle? What would it be if it's not comets?
Realistic assumptions. The idea is that some of those have been flung out. Maybe Jupiter flung some of the original ice in the solar system out to the extremities, but the simulations I've seen of that don't get nearly enough of them out there to make an Oort cloud. So it's problematic if it's there, and it's problematic if it's not there. But since there's no evidence for it, I presume it's not there.
Right, great response. I've even seen a lack of confidence sometimes in the response from the uniformitarians and the evolutionists with the Oort cloud. So great response. So the next,
in the side chat, David Neff makes a good point. He says the comet Hyakutake, has a period of over 70,000. I'm assuming that's 70,000 years, 70 KY, 70,000 years. I'm assuming that is. The K being 1,000, the Y being years. I might be wrong on that, actually. I don't know a lot about the labeling, the notation that is used for labeling things in astronomy. I'm more astrophysics than astronomy, so... And yeah, C2006P1, I have heard of that before. It has over 90,000 years. Again, I'm assuming that's what that means. Correct me if I'm wrong on that notation, David, by the way.
next question then is a very common one, especially for you, I'm sure, Dr. Lisle. I want to first say great job in your latest informal debate with Dr. Hugh Ross.
Thank you.
I think I can speak for everybody when I say you really demonstrated just how scientific the young Earth creation model is. Now, the topic of distant starlight was brought up in that debate, and you gave some really great responses that I believe were not well countered or responded to. So my question would be this. Given the biblical timescale that God created the universe roughly 6,000 years ago, how are we able to see stars and galaxies that are billions of light years away?
So, before we dive into that question, I dearly apologize. I do need to run to the bathroom. Give me about 30 seconds. Stick around. I will definitely be back. By the way, for those interested, I am far from the only streamer that does that. If you're wondering why I'm going to the bathroom, this would be why. Kugel's Oktoberfest. I've been drinking that. I figured I'd pick up, a nice brew to drink. I'm just going to fill my cup and then, you know what? Why don't I play this while I'm doing that so that we have some material to respond to? By the way, yes, there are numerous streamers that I watch. Vosh is one of them that go to the bathroom in the middle of streams. What can I say? We're all humans. Sometimes we have to go to the bathroom. It's just a human thing. But, what are you going to do? What are you going to do? By the way, if you're enjoying this content and you're not yet already, please consider subscribing. I would really appreciate that.
There's more than one way God could have done it. The method I think that he used doesn't involve any kind of supernatural activity at all. Of course, God can do miracles. That's not a problem for God. So we dare not say, well, I don't understand how you could have done that, God, therefore you didn't do it. That's absurd. I mean, you'd have to eliminate the resurrection.
Yeah, that's absurd. I mean, humans rising from the dead, that's okay. Turning one chemical into a completely other different chemical is okay. Literally walking on water as if it were a solid surface, that's something with significant mass that is somewhat buoyant but not very buoyant in water, walking on top of it, that's okay. But saying that you can't do those things, oh, that's absurd. That's absolutely absurd. I would never. But hey, when you've got God magic, anything is possible, right?
Turning water into wine and all these things. But the way that I think that God got the light here is I think that the Bible is using a synchrony convention that's different from our modern synchrony convention. Now, what's a synchrony convention? That's the idea that two clocks separated by distance are synchronized. Well, how do you decide if two clocks separated by distance are synchronized? Now, if the distance is short, it's pretty easy. You just look at them and you say, well, they're both synchronized. But if light takes some time to get from that clock to your eyes, then that might be a little bit of a problem. They might look synchronized, but in fact, one of them's a little bit ahead of the other. But it took more time for light to get from one than the other. So you see, it becomes a little bit of an issue when the clocks become separated by cosmic distances. And it turns out, this is something that Einstein wrote about, it turns out that there is no objective way to synchronize two clocks separated by a cosmic distance without assuming the speed of light in one direction. And when I mean the speed of light in one direction, most of the experiments that have been done to measure the speed of light involve either directly or indirectly a two-way trip. It's like you're taking light from a source, you're sending it out, bouncing it off a mirror, and bringing it back, and you're measuring the total time, total distance, and you divide the distance by the time. That gets the average velocity. And a lot of times people...
I need to stop there. That doesn't give you the average velocity. So what he's talking about is a synchrony convention or a synchronicity convention, whereby what we're doing is... So the point that he's getting at, just to kind of... I don't want to say it as dumbing down, because that assumes you all are dumb, and most of you are far from dumb. Unlike, I would say, maybe Jason Lisle. Of course, I don't think he's dumb. I just think he's a fucking liar. So if you have two clocks sitting at the same spot, but you want to move one away so you can measure the light from point A to point B, the minute you start moving that clock, regardless of what speed you're moving it at, it is now subject to special relativistic effects. So that when you separate the clocks, when the clocks are finally separated, one of them will be ticking. They will be ticking offset. Now, this might even be by extraordinarily minute amounts that no human could even conceivably detect. But the light that you are sending from one clock to the next, or rather detectors attached to those clocks, will be able to know that. So you will never be able to precisely determine what the speed of light is from point A to point B. This is why I say that there's no such thing as a one-way speed of light. Because you can make it whatever you want, and then fudge the math to make it equal to c based on the speed that it is going from point B back to point A. And he's going to get to that with his particular method. So what he's saying here is that if you separate two clocks, the act of separating them, physically moving them away, changes their synchronicity. They're no longer synchronized even by extraordinarily small amounts. Even if by extraordinarily small amounts. So how do you ever measure the speed from point A to point B? You can't do it. You have to measure it from point A to point B and then back to point A. He is assuming the speed is changing somewhere in there when there isn't any reason for that assumption. Let's continue.
People assume that it takes the light the same time to go that way as it does to go that way.
No, you're assuming that it doesn't. There's every reason to think that it does. And I will dive into a little bit more about synchrony conventions once Dr. Lisle here starts getting a little bit more into it.
We don't really know that. And in fact, according to Einstein, it's impossible to know that. People say, why would it be different in different directions? Well, I don't know, but there's no reason why it would have to be the same either. And I found the concept's a little bit difficult.
By the way, just so everybody knows, the glitching that's going on is not me. That's on Standing for Truth's channel.
For layman to grasp, because it takes a little bit of knowledge of the physics of Einstein. And so I actually wrote a book about this topic called
I know the Physics of Einstein,
where it brings people up to speed on the physics that they would have to know in order to recognize why you can't actually objectively measure the one-way speed of light, because you need two clocks that are exactly synchronized, and there is no objective way to do that in the universe. There are subjective ways to do it, where you can say, I'm going to call this synchronized. Somebody else is free to disagree and say, no, I don't think they're synchronized. I think they'd be synchronized if this one was turned a little bit ahead of that one, so that now they're synchronized. And the bottom line is, if you use the ancient method of synchronizing clocks, which is a visual synchrony convention, clocks are synchronized if they look like they're synchronized, basically, then light takes no time at all, even today, to get from those distant galaxies to the Earth, and so it can actually arrive instantaneously.
I did want to point out really, really quickly that back during the time when the Bible was written, from the oldest points of the Bible to the youngest, they didn't even know what light was. They thought it was some immaterial thing. They didn't know that it was physical. They didn't know it was a wave. They didn't know anything about it. They didn't know that it could be measured. None of that. They didn't know that. So when he talks about the synchrony convention that was used when the Bible was written or what have you, there wasn't one. They didn't have that. They had no understanding of special relativity. They didn't even have a basic understanding of that stuff. They didn't even have much of an understanding of algebra back then, although they did have some understanding of it. Certainly not linear algebra or calculus or anything that's required in special relativity. So, like I said earlier, you would think that a PhD would know these things. I think that he does, but that he's just pandering to a particular audience and so can say whatever the fuck he wants because, well, he's the authority here. He knows these people aren't going to go and fact check him, and they don't really have the knowledge to show him that he's wrong. This is why he only debates academics. Funnily enough, it seems that he only debates academics that are also Christians. He wouldn't debate somebody like Sean Carroll or Lawrence Krauss or Roger Penrose or anybody like that. He wouldn't debate somebody like that because he knows they'd spank him across the stage back and forth the whole time.
And that doesn't violate any physics. It's actually perfectly consistent with the physics that Einstein discovered. It's just that a lot of people don't know about it. And I know that's a little bit abstract. I found that it takes probably at least 20 minutes really to bring people up to speed on the basic issues so that they can comprehend the thrust of the argument. But I do have a series of articles on our website at biblicalscienceinstitute.com. Our latest articles are on this very issue. I've been bringing people up to speed on the starlight issue, some of the other solutions that have been proposed, and why I think this, what I call the anisotropic synchrony convention, is the best method. It's consistent with the physics of Einstein. Nobody can disprove it. It makes sense historically. And in that model, light can get from the farthest galaxy to the Earth immediately. It takes no time at all. And therefore, there is no distant starlight if you understand physics.
He's not wrong here. If you use what's called the ASC, the anisotropic synchrony convention, this proposes that light actually travels from point A to point B, so like say from the sun to the Earth, infinitely fast. Like it gets here immediately, instantaneously. But the time that it takes it to be, say, reflected off the Earth and go back to the sun is half the speed of light. So that the average over the point A to point B, back from point B to point A, would be c, the speed of light. This actually fits in with all of physics. It does. We could use the anisotropic synchrony convention over the Poincare-Einstein synchrony convention, oftentimes just called the Einstein synchrony convention, or ESC. So if I say ESC or ESC in this video, I mean the Einstein synchrony convention or the Poincare-Einstein synchrony convention, and ASC is the anisotropic synchrony convention. They're two different ways of essentially measuring the speed of light. Kind of like the difference between feet and meters. They're just different conventions for measuring something. You can use ASC and have our universe be exactly the way it is. Something I want to clarify is that ASC does not posit that the Earth, or rather that the universe, has to be 6,000 years old. That's nowhere in ASC. ASC is just a different way of measuring the speed of light than the ESC is. Likewise, using meters to measure the point from your house to, say, your grandma's house is just a different convention of measuring than, say, using feet. But neither one is really right or wrong. But that being said, it doesn't matter which convention you use, inches, feet, meters, leagues, fathoms, it doesn't matter. The distance itself remains the same. I just wanted to point that out. This will become relevant as we continue in the video.
Awesome, that was a great answer. Matter of fact, even going back to your debate 2 months ago with you, Ross, you objected that your distant starlight argument by asking, when we look at the sun, do we see the sun as it is now or as it was 8 minutes ago? Right. So it appeared that by asking that question, Hugh Ross didn't fully understand the physics of Einstein. Now, what would be the best response or argument to that specifically?
Yeah. When he asks, is it this or that? It's like asking, is a table 3 feet long or is it 1 yard long? And of course, the answer is both. Depends on what units you choose to make the measurement with.
True.
And so whenever anybody asks that question, does it take light 8 minutes to get from the sun to the earth, or does it get here instantaneously, or 16 minutes? And the answer is it depends on the synchrony convention that you choose. There is no objective answer to that question. People get frustrated because most of us have a view of time that it's sort of absolute and universal. It's the same everywhere. Clocks all tick at the same rate. And everything, you don't have to worry about these synchrony problems. But Einstein discovered that is not the case. Time is not the universal objective thing we think it is. It's affected by motion, gravity, and things like that.
Yes.
And so
yes.
the amount of time it takes light to get from A to B and back to A, that's objective, and that time is objective, and there's no getting around that. The round trip speed of light is set by God in vacuum. You can't change it.
That made no sense. Like, God doesn't set anything. Nobody can verify that. So what he's saying here is technically not incorrect. It is technically correct. You can make the one-way speed of light literally anything from negative infinity to minus infinity, as long as the two-way speed of light from point A to point B back to point A equals c. The problem here is that, to give sort of an analogy, there's a reason why at least the vast majority of the world utilizes the metric system over the imperial system for measuring. It doesn't really matter, but one of them is much easier to work with, not just intuitively. I mean, being, more of a base 10 measuring system. There's 10 millimeters in a centimeter, there's 100 centimeters in a meter, there's 1,000 meters in a kilometer, things like that. Much simpler than, 12 inches in a foot, 5,203 feet in a yard, 5,280 feet in a mile. You get these random ass numbers. So it's much simpler intuitively, but it's also much simpler mathematically. We can, like I said earlier, use the ASC, the anisotropic synchrony convention, and have a universe that looks exactly like ours does right now. It's just that it needlessly complicates the math, and that's why the vast majority of the fields relevant to this don't use it. They use the Einstein synchrony convention, where the speed of light is constant. From point A to point B, it would be 186,282 miles per second, or 299,792 kilometers per second, and it would be the same from point B back to point A. The one-way speed of light can't be measured, because we already talked about that with special relativity and synchronizing clocks. So the one-way speed of light is pretty much a non-existent thing. You can't ever measure it. You can make it whatever you want, whatever you can dream up. It's just, it comes down to what mathematically makes the most sense. What's the easiest? And that's the Einstein synchrony convention, where the speed of light is constant no matter which direction it's moving, no matter how you're measuring it. It's a constant. And this is what we've based all of our physics on. So, like I said, he is technically correct here, but there are reasons why we used ESC, Einstein synchrony convention, over ASC, anisotropic synchrony convention. It's easier intuitively and mathematically. It's sort of an Occam's razor thing. Why complicate things beyond the level that they need to be complicated? It just makes no sense. So that's why we use ESC and not ASC.
But the one-way speed depends on how you choose to synchronize clocks. And so
yes.
Does light take 8 minutes to get from the sun to the earth, or does it take no time at all, the answer is yes. And the same is true for distant stars. Does it take years for their light to get here, or does it arrive here instantaneously? The answer is yes. It depends on which synchrony convention you use. And I believe the Bible is using the more ancient synchrony convention, in which the celestial events are marked by when you see them. And so, using that system, God created the entire universe. The light was immediately visible to Earth on day 4, as soon as God created the luminaries. And that gets around a lot of these other issues too. Of people say, well, God made the light already on its way. Well, then He's making pictures of things that don't exist. This gets around all that, because all the stars that we have pictures of really existed in real time. It's just that we see them immediately.
Oh, I love it. Great answer. We've got a lively chat who are really enjoying this and who really enjoyed your debate with Hugh Ross a couple months ago, and share my opinions with it. Here we've got Tony Torp. A question came in. Hi, Jason. Has anything been heard from Hugh Ross when you challenged him to read your article, Distant Starlight and ASC, in your last debate? Thanks for your new post on the subject. They are awesome.
Thank you for that. No, I haven't heard from Hugh Ross. I hope that he did look at that article, because he was under the mistaken impression that light from a supernova could be used to measure the one-way speed of light. It cannot. And I had already answered that, because there was a critic named Peter who had posted that same thing, and I demonstrated that, in fact, Peter had made the assumption in his question that the speed of light's the same in all directions. Otherwise, his question wouldn't make any sense. The fact is, you get exactly the same answer or when you see the light from a supernova that's been gravitationally bent. You get exactly the same answer, whether the light in one direction is instantaneous, or whether it's C, or whether it's any other value. That's
Very true. This is because gravity doesn't slow light down. Light cannot be slowed down. A lot of people will say, well, what if it's traveling through a medium? I've always heard that, if light travels through some sort of medium, it slows down. It actually doesn't. It's just that its trajectory, instead of being straight, is being changed. So the best way to describe this is if you know what a vector is. A vector has two arguments, or two quantities, that define what it is. Its length and its direction, or you could even say orientation in a three-dimensional space. Only one of those arguments changes when light hits a medium. That is the direction vector, or the direction argument rather, not the speed. So what happens when a photon enters a medium, is a medium being some sort of matter, is that it is absorbed by an electron, and then might be emitted by that electron, but then absorbed by another electron. So in the time between being emitted from one electron, but before being absorbed by the other electron, that photon is still traveling at c, at the speed of light. So its speed doesn't change. It's just the direction changes from being straight to being whatever it is, jumping around from all the electrons that make up the outside shells of those atoms, so to speak. So literally nothing slows light down. You can change light's trajectory, which can change the rate at which it propagates through a medium, but its speed doesn't change, because remember, only one of the arguments of that vector are changing, not both of them.
Wow. And the reason for that is light can only be instantaneous in one direction relative to a given observer, and so the light from the supernova would have to go at an angle, and so it wouldn't be quite instantaneous when it first goes out until it gets bent around the galaxy and then zips directly toward the observer. And so I answered that, and Hugh hasn't got back with me yet. I hope he will. If he wants to, if he thinks I'm wrong, he's welcome to challenge me, and I'd be happy to post his reply, and I reply to his reply, and so on.
Awesome. Yeah, great response. I mean, it looks like oftentimes I find that the critics, even some of the most militant critics, just aren't really up to date on the literature on this anyways.
Yeah.
I assure you I am.
You kind of answered this, but a question would be, how do you feel the critics have responded to your arguments overall, Dr. Lisle, on distant starlight in a young universe? For example, as you're covering here, the one-way speed of light and synchrony conventions. In other words, have they provided any sufficient rebuttals? And if possible, and you did cover a couple here, what are the best possible responses to those rebuttals?
I haven't seen any serious rebuttals, to be honest with you. People who are physicists and are trained in relativity have Some of them have said, well, Lyle's right about that. So, and of course,
I do want to clarify really quickly. He's right that you can use ESC or ASC and have the universe look exactly the same. Just like you can measure something in feet or you can measure it in meters. It doesn't matter. I was waiting to say this, but I guess Dr. Lisle doesn't ever really bring this up, at least directly, but the problem is he's using ASC rather than ESC. Now, there isn't anything immediately wrong with that, other than that it complicates the math way more needlessly than it needs to be complicated. It's just needless complication of the math, like using the imperial system over the metric system, as I mentioned earlier. It's just, why would you do that? The math is harder. You know, you got 12 inches in a foot, 5,280 feet in a mile, when you can do 10 millimeters in a centimeter, 100 centimeters in a meter, 1,000 meters in a kilometer. You know, it's all base 10. It's really easy to work with. It's intuitive. It makes sense mathematically. The problem is that Dr. Lisle's model isn't just we use ASC and that's it. It's that we use ASC and we use that to justify or to argue for the Earth being only 6,000 years old. Essentially, it's a way of eliminating the distant starlight problem by utilizing a different convention whereby you argue that, well, starlight gets to us instantaneously, so it doesn't matter how far away something is. The universe could be whatever age you wanted it to be, utilizing the ASC, because light gets to us instantaneously. So his argument is not, or rather his model isn't just we use the ASC and that's it. It's we use the ASC, but we use that to justify a 6-day creation, that not just the Earth but the entire universe is only 6,000 years old. So he adds all these other already demonstrably false aspects to his model that the scientists he's mentioning now don't accept. They'll look at him and say, hey, if you want to use the ASC, there's nothing wrong with that. But when you want to add in that the universe is only 6,000 years old, or that, it was created literally in 6 days, now you've got a bunch of problems, because we literally know that all those are false, explicitly. So there's a difference between using ASC and just choosing to use that convention rather than ESC, just like if you chose to use the imperial system over the metric system. You're not wrong. You're complicating the math a little bit more. It's a little less intuitive, but you're not wrong. You'll measure the same distance of a 3-foot table as you would utilizing the metric system. But to then argue that there's all sorts of things about the table that are somehow true because you're using the imperial over the metric system, that doesn't work. So he's not just saying we use ASC. He's saying we use ASC because it allows us to argue for a 6,000-year-old Earth. So I just want you guys to keep that in mind.
Some of the papers that promote an ask-type model, like the one by Sarkar and Stachel that I like to point out, and the authors are not creationists, but they agree that light can get here instantaneously using the correct synchrony convention. So I haven't seen any real. I've seen internet rebuttals by people who don't seem to be trained in relativity.
I did want to point out really quickly, because you gotta give credit where credit is due. You just have to. Jesus is Lord says, only if the Bible actually taught the age of the Earth, you would be making some ground. Well, he's actually right. The Bible does not technically teach the age of the Earth. The 6,000 years, or whatever it is, the roughly 6,000 years, was determined. It was somewhere between the 1400s or the 1600s. Somebody might look up the date and correct me if I'm wrong, but it was determined by somebody else utilizing a sort of a timeline that's in the Bible. So the Bible does not ever actually explicitly state how old the Earth is. And it's even been said by numerous historians that if we could talk to the people who wrote the Bible and say, is the Earth or the entire universe only 6,000 years old, they'd probably laugh at you, because that wasn't written into the Bible. That was something that was extrapolated from the timelines in the Bible by somebody else. So I have to be honest here. Jesus is Lord is technically correct when he says that the age of the Earth isn't really in the Bible, but it's not me that's failing to make ground based on that. It's Dr. Lisle here.
I've seen one that says, well, no, you can't use that coordinate system where it would create a gravitational field, which we don't see. No, that's not the case. Switching coordinate systems does not create a gravitational field. You can measure things in polar coordinates, you can measure them in rectangular, you can measure using an Einstein synchrony convention, or the anisotropic synchrony convention. It doesn't create any magnet or any gravitational fields. And anyway, most of the ones, if you go back a few months back on my website where I respond to Peter's objections on distant starlight, most of the ones that I've seen on the internet, he repeated those and I answered them. So I haven't seen any ones that are a serious challenge from a physics perspective because, frankly, the conventionality thesis upon which my model is based is really pretty well established. I consider it proved. John Winnie, back in 1970, showed that all of special relativity can be done without the one-way speed of light, leaving it as a free parameter. Which
That is correct. The one-way speed of, because, and again, that goes back to the one-way speed of light is an indeterminate quantity. It essentially doesn't exist. By all rights, you might as well just think of it as not existing. You cannot measure the speed of light from just point A to point B. You can't do it. You can make, and like I said earlier, you can make that whatever quantity you want, as long as you can fudge the math to make the two-way speed of light equal to c. It doesn't matter what the one-way speed of light is. It could be from 0 to infinity. It doesn't matter. But again, why needlessly complicate the math if you don't have to?
the epsilon, the Reichenbach epsilon. So I haven't seen any rebuttals at all, really, other than ones that are kind of on the internet, not peer-reviewed ones.
Right, you're going to get that with everybody, though. I mean, you
Sure.
see that everywhere. The internet,
Of course.
the internet's the criticism area. So here's one. You did answer at least the first part earlier, but I'm just going to read the entire thing for you because this was a critic question. So the objectum, for the sake of argument, let's accept that your claim for the round-trip average speed of light is 186,000 miles per second. If this is true, and this is the one-way speed of light, then in order to accommodate a 6,000-year time frame, these specific critics have stated that there is no simply no reason to think that the one-way speed of light is over 700 times faster than the round-trip speed of light.
Well, when
I believe it was David Neff, actually, that posed this question. I guess you would. I don't know if he's still in the chat, but I guess you would have to ask him if he thought that Dr. Lyle's response was adequate.
people state things that way, that suggests to me that they're not understanding the physics of the situation. It'd be a little bit like saying the metric system is clearly the correct way to measure things and not the English system of feet and inches. I mean, because 12 inches in a foot, I mean, that seems unlikely. Whereas meters, it's 10 centimeters, 100 centimeters in a meter and so on. That's all 10. That's nice and neat. Nature clearly prefers metric over English. Well, no, it doesn't, because you see, when it comes to a convention of measurement, you can't use Occam's razor. So, well, it's more likely to be this than that. No, it isn't. It's your choice. The English system, in terms of inches and feet and foot-pounds and so on, it is a lot more complicated. It's hard to keep track of than the metric system. It is. That's why scientists, we like metric. And we do all our...
There's a good point to make here. What he's referring to is not that the speed of light ever changes based on how you measure it. Just that you can measure it utilizing whatever method you want, as long as it returns accurate results. Just like I said earlier, you can measure a table that's 3.32 feet long. That's 1 meter. You can measure it in feet and get 3.32, or you can measure it in meters and get 1. But it doesn't matter which one you use. The table stays the same length. You can measure it and say it's 37 glurgs, or 56 blurps, or 29 Glubishblockens. I mean, you can make it whatever you want. But that doesn't change the length of the table. Just like measuring the speed of light using the ASC over the ESC doesn't actually change the speed of light to being instantaneous. It's just you're measuring it that way because you choose to. And again, that's why Dr. Lisle chooses to measure it that way, because it eliminates utilizing that particular convention over the one that literally every relevant professional in the field is using. Eliminates this distant starlight problem. He's using it as a rescue device for arguing that the universe is literally only 6,000 years old. That's it. Measuring something in a variety of different ways never changes the objective parameters of what you're measuring. It simply changes the method you're using to measure it. And it's the same thing between the ASC and the ESC. They're different methods for measuring the same thing, but what you're measuring isn't changed by how you measure it.
our calculations in metric, and then if we need to convert at the end, we can. But that doesn't mean that English units are wrong. And it's the same way with the one-way speed of light. It's not that it's this or that or the other. It's what you choose it to be, and that will tell you how to synchronize two clocks that are separated by distance. And I know that's counterintuitive, but folks, if you're gonna if you're gonna argue on this principle, you need to get up to speed on the physics of this. This has been discussed. This topic of the one-way speed of light and its immeasurability has been discussed for over a century. There's a century worth of.
So I did really quickly want to answer a question from James Downard. He says, is Lisle arguing that the speed of light varies now, or only that it did so back in the Bible time and never since? He's not arguing that it varies, just that light comes from a source to us instantaneously. So we see the sun not as it was 8 minutes, 19 seconds ago. We see the sun as it is now. So what he's arguing is that when you use the anisotropic synchrony convention, and this is true under the anisotropic synchrony convention, light goes from a source to any potential receptor instantaneously, which already is violating special relativity of simultaneity, and numerous other principles in special relativity, which tell us that you can't actually have anything instantaneous or simultaneous. But he's not arguing that it actually changes, just that if we use this particular way of measuring it, it gets to us instantaneously, but travels at half of c, going back to from where it was received back to the source. So hopefully that answers your question. And I do want to again reiterate, there's a reason that the vast majority of professionals don't use this particular system, just like there's a reason the vast majority of people on the planet don't use the imperial system. It needlessly complicates the math.
Literature out there devoted to this topic. And not long ago, I came across a book somebody had written. Max Jammer wrote a wonderful book called Concepts of Simultaneity from Antiquity to Einstein and Beyond. And it's a nice summary of the scientific literature, written really pretty much at a layman level. And so that's a nice way to get up to speed on these issues. But when people say, well, it's more like the speed light's more likely to be this than that, or there's no evidence that it's one way or the other. No. This is a convention of measurement. It's a convention by which we decide what we're going to call synchronized. When we have two clocks separated by distance, that's all it is. And that's why there is leeway in terms of how you choose to set the one-way speed of light. It's not something that can ever be measured. It's because it's not an objective property of the universe. It's a human choice.
Right, that's a great response. These critics, like you said, Dr. Lisle, they need to get up to date on this. This physics, as you said, is known, and
it's not that the critics need to get up to date. It's that Dr. Lisle needs to get up to date and understand that the people that are criticizing him aren't using the measuring methods that he's using. This would be like if somebody in the United States were arguing, well, we should use the imperial system. You're going to have a lot of critics, especially in engineering, physics, mathematics, medicine, all these different fields, saying, no, we prefer the metric system because it's much more intuitive, it's much simpler, and it doesn't needlessly complicate the math. If you said, well, these critics need to just get up to date with it. No, they really don't. They're just using a system that returns less complicated results more efficiently than yours does. Why would you not want to go for a more efficient, less complicated system?
It's understood. And it's probably why you have not
system of measurement, by the way.
So that's a great response. This is awesome. A couple super chats I should get to. The chat's lively, and I may miss these. So $10 super chat from Conservative Christian. Thanks so much. We appreciate it. Dr. Lisle, would SN 1054, the supernova observed in 1054 AD, prove your theory of distant starlight? It was witnessed in real time, meaning it didn't take millions of years for the light to reach us.
I can't remember how he answers this, but under the ASC, yes, we saw it instantaneously. But again, nobody really actually uses that unless they're like Dr. Lisle here, and are trying to argue for a young Earth. Given that we use the ESC, the Poincaré-Einstein synchrony convention, or just the Einstein synchrony convention if you'd rather, that supernova occurred about 6,500 light years from us. So it occurred 6,500 years prior to 1054 AD. So no, we did not technically observe that when it happened, at least using the ESC. And I think I've already explained why the ESC is much, much more useful to us than the ASC.
Okay, I would say it doesn't disprove my model, but it doesn't prove it either.
Now, the fact that he says that, it doesn't disprove it, but it doesn't prove it. What he just admitted there, and this is really, really important, this is really critical, especially within the framework of science, like as Dr. Lisle is a scientist, at least I presume he's a scientist. He just admitted that his model is unfalsifiable. You can't prove it wrong, but you can't really ever prove it right either. You'll notice this a lot with conspiracists like creationists, or even flat earthers, or climate contrarians, anti-vaxxers, is they'll say, well, you can't prove me wrong. You can't prove me right, but you can't prove me wrong. As if that makes them, that makes their case stronger. It doesn't. It just shows that the model you have is unfalsifiable, and it is thereby, by definition, unscientific. He just admitted his model is unscientific.
Because if you use the anisotropic synchrony convention, that explosion actually happened in 1054 AD. That's, by the way, the explosion that produced what today is the Crab Nebula. And the Crab Nebula is still expanding, and so we can actually work it back and figure out when it exploded. You get roughly the right answer. We know from history, we know from recorded history it was 1054 AD. And so one of the exercises I have my students do is to try and estimate what that date was. And they get an answer usually pretty close to the right date. But so that it's just a question of whether that actually happened in 1054 AD or whether it happened previous to that. And that, by the way, that supernova remnant, it's not millions of light years away. That's well inside our galaxy. I don't remember its distance, but it's a few thousand light years away. So even if you assume the Einstein synchrony convention, that would just mean it actually happened sometime probably before Christ's earthly ministry, the actual explosion, and then we finally saw the light from it in 1054. Whereas if you use the anisotropic synchrony convention, then it actually happened in 1054 AD, and we saw the light immediately. So there's no way observationally to distinguish between the Einstein convention and the visual or anisotropic synchrony convention.
Awesome. Yeah, this stuff's so fascinating, Dr. Lisle, and you make it so understandable for us. So I want to thank you for that. Question here from Vitalis. At SFT for Dr. Lisle, do you think light is subject to anthropic forces due to a closed system universe?
I don't know what he's referring to. I don't think I understand the question.
No, that's fine.
Of course, we don't know if the universe is closed anyway, so I don't know how I could answer that even if I understood what he meant by it, really.
No problem. Vitalis, if you can clarify at some point, then maybe we can get back to that. So the next question, Dr. Lisle, would be, we often hear that cosmic background radiation is evidence of an old
here
universe.
We go. We get into
what would be
some
the best
juicy
response
stuff
to
here.
a claim such
Juicy.
as that?
So
I
juicy.
think the best response would be why. How does that in any way prove that the universe is old? People say, well, it's evidence for a big...
Yeah, it proves the universe is old because we know how the cosmic microwave background was emitted, and we can trace back to when it was emitted by just looking out into the universe. Now, you have to remember, he's arguing from the ASC model, not the ESC model. So he's always against the majority of people in his own field. But there are numerous reasons. I wish I could... I might be able to link it here. There's an article by a Ph.D. theoretical astrophysicist, Ethan Siegel, who's a senior science contributor for Astronomy Magazine. He wrote an article, not Astronomy Magazine, my bad, Forbes Magazine, there we go. And he wrote an article about how we know that the cosmic microwave background is left over from the Big Bang. If I can find it here, I might be able to put it in the chat for you guys. Because it is a really... Actually, yep, I just found it. So let's see if I can get it in there for you guys, and I'll let Dr. Lisle provide his asinine response to this.
Bang, I've said, why? The cosmic microwave background, by way of explanation, if you could see microwaves, you could go outside at night and the sky would be glowing faintly with microwaves coming from apparently all directions in space. Now, secularists assert that's leftover radiation from the Big Bang. But
That's
how
because
do you know
it is.
that's leftover radiation from the Big Bang? You don't know that.
We do know that. If you want to know how we know that, just click on the link that I put and listen to a PhD theoretical astrophysicist who's won numerous awards for his science communication tell us how we know that.
And all we know about it for sure is that it's there. In terms of where it came from, we don't really know. Now, I don't have a specific creationist explanation for it either, but that doesn't automatically.
So what he's saying here is, well, I can't explain it, but you can't explain it either. Your model doesn't work. I mean, I can't replace your model with a better one, but that doesn't mean that your model is correct. It's denying something simply for the fact that it disagrees with your position, despite you not being capable of providing a better model to replace it. This is just asinine. And the fact that this is coming from a PhD astrophysicist who should know this shit, this is why I say, I mean, he's just lying. He's fucking lying. It's explicit.
I mean, the secular explanation is right. The fact is, the universe has an average temperature. It is glowing. And that glow appears to be coming from all directions in space, but that doesn't mean it's leftover radiation from the Big Bang. It could be, I don't know, it could be the original light that God created and used for the first 3 days, and maybe he stretched it out. And then it became redshifted to the point, where it's, I mean, I don't know. The interesting thing about the cosmic microwave.
Did everybody get that? Well, I don't know what it is. I don't know where it came from, but it didn't come from the Big Bang. Textbook argument from ignorant. Oh my god, this is just humor at this point. Holy shit.
Background is it doesn't really have much in the way of spectral lines in it.
Wait, what?
Except for those that have been imprinted on it by intervening material. And that's interesting because...
Oh, holy fuck. It doesn't have spectral lines because it's black body radiation. And because of the way that black body radiation is emitted, it doesn't have spectral lines. He's a fucking PhD in astrophysics. He should know this. I have no degrees in anything and I know this. How the fuck does this guy not know this stuff? But he does know this. He's just lying. I mean, look at him. Look at his weaselly little fucking face. He's a weaselly little fucking liar. He's lying through his fucking teeth. This is just asinine. This is absolutely insane. How a PhD in astrophysics is saying, he's only saying this, like I said earlier, because he knows his audience is going to lap up whatever the fuck he throws out there, and that they're not smart enough to fucking fact check the bullshit that he's spewing. Oh my god, this is stupid. And if you don't believe me, then just click on the link that I provided to Forbes magazine and it will explain the same things that I just explained.
Because all natural sources of light have an imprint on them of the atoms that made them. That's how we know what stars are made of. We break the light down from the star and it's missing certain frequencies of light are missing, and that tells us the substance that created that light. It's kind of an atomic fingerprint, and the cosmic microwave background seems to lack that atomic fingerprint, almost as if it was supernaturally created. So I think that's kind of it.
Yeah, it lacks spectral lines because it was a black body radiation. It is a black body radiation instead of being emitted from something that's not technically considered a black body, like a star. But no. What that really means is that it was a bunch of God magic. It was God magic that created it. That makes sense because we all know that photons are created through magic.
Interesting. We don't even know it's a background. It might be relatively nearby. We don't know that.
Oh! What? What? Holy shit! Holy shit! We don't even know if it's a background. I mean, it might be... Oh! I'm sorry. Let's back that up. Just a little bit. Just a little bit. So we can hear that again.
Cosmic microwave background is it doesn't really have much in the way of spectral lines in it, except for those that have been imprinted on it by intervening material. And that's interesting because all natural sources of light have an imprint on them of the atoms that made them. That's how...
No, not all sources of light have that. Black body radiation is a source of generally infrared radiation. It is a source of electromagnetic radiation, and it doesn't have spectral lines. How the fuck a PhD can get away with saying this stuff? See, this is why he's not a professor, or why he's not a researcher at any major institution. Because he's fucking lying through his weaselly little teeth.
All we know what stars are made of. We break the light down from the star, and it's missing certain frequencies of light are missing, and that tells us the substance that created that light. It's kind of an atomic fingerprint, and the cosmic microwave background seems to lack that atomic fingerprint, almost as if it was supernaturally created.
Magic!
So that's kind of interesting. We don't even know it's a background. It might be relatively nearby. We don't know that.
I'm sorry. We don't even know if it's background. It might be really... It's everywhere! That's what the fuck a background means. It's close to the Earth. It's far away from the Earth. It's close to Jupiter. It's far away from the Jupiter. It's in the solar system. It's outside of the solar system. Because it's a fucking background radiation. It literally permeates the whole of space-time. That's what the fuck background means. This is what I said. Look at his fucking face. He's a weaselly little fucking liar. He knows the shit that he's saying is wrong, but he's saying it anyway. This is fucking insane. I have never in my life heard a PhD in a subject be this fucking wrong on the subject that they're talking about. Oh my fucking god. Let's continue.
But it doesn't prove a Big Bang. It certainly doesn't prove billions of years, because we don't know where it started from. And in any case, if you accept my explanation of this starlight, that'll work on cosmic microwaves as well.
Except that we know that when the CMB, the cosmic microwave background, was released, it wasn't low microwave radiation. It was high-intensity X-ray, if not gamma-ray radiation, when it initially decoupled from matter in the early universe, about 379,000 years after the Big Bang, when the universe expanded enough so that it cooled down enough to allow for matter to form, or to allow for the hot soup of protons and electrons to form stable neutral hydrogen atoms, at which point the photons decoupled from it and were capable of streaming freely through space. So we do know how old it is because it's also been redshifted. We know that the cosmic microwave background has been redshifted, so we know how old it is. This guy is just fucking lying. This is insane. How the fuck can you be a professional in a field and be allowed to lie like this? Well, that's right, because he doesn't let anybody who's actually a relevant professional in the field ever refute him, because he knows he would fucking lose in the first 5 minutes.
They can get here instantly using the anisotropic synchronous convention.
Awesome. Perfect answer. I appreciate that. Maybe this helps clear it up. Vitalis said entropic.
Entropic. Okay.
Autocorrect, I guess, messed that up.
Okay, so does light suffer entropy, I guess, would be the question. Well, everything suffers entropy. Entropy is a tendency of energy to go from a useful state to a less useful state. Things are winding down, so to speak. And that is something that the universe being closed in the sense it's a closed system. I see what he's going at.
No, actually, the universe is not a closed system. An open system in thermodynamics is a system in which both matter and energy can freely move between the system and whatever environment surrounds its outsides. A closed system is one in where I believe it is energy can move between the system and its surrounding environment, but not matter. I might have that backwards. Somebody correct me and post it in the chat. But I think it's energy. An isolated system, like our universe, is one where neither matter nor energy are capable of moving between the medium, whatever medium might be surrounding our universe, which there probably isn't one, and the universe itself. And the reason that the universe is an isolated system is because it's most likely the case that there's literal nothingness outside of our universe. There's no such thing as outside of, or beyond, or above, or below with our universe. The term just doesn't make sense. It would be like asking what's north of the North Pole. It's an incoherent question to ask.
The universe is a closed system in the sense that there's no energy allowed from outside the universe. If the universe is all that there can't be energy from outside, accepting the secular view of it for the sake of hypothesis. So yes, everything would be subject to entropy, including light. So in fact, when light strikes a substance, it tends to heat up that substance, and then it can re-radiate, and it sometimes re-radiates in lower frequencies. Maybe you get 2 photons instead that are lower frequency, and that would be a higher entropy state. So
that is
light,
true,
like
yes.
everything else, suffers the effects of entropy. And what that does is it shows us that the universe cannot be infinitely old, because there are
No, it doesn't show us that. The universe could easily be infinitely old, mainly because, as Dr. Lisle here has already admitted, time is tenseless. Time is not like we think it is. Our universe could have started in a low entropy state for a whole host of reasons that we just don't understand because we do not have an understanding of the earliest moments of our universe. It is completely wrong to say that there's no possible way that our universe could extend infinitely into the past. Could it extend infinitely into the past in the current structure that it has? No, because of entropy. But for reasons that may be unknown to us, there could be an explanation for why the universe is low entropy that have something to do with something extending infinitely into the past, and we just don't know about it yet. There have been numerous models that have been proposed that have our universe extending infinitely into the past. I'm not going to say that any of them are correct, but I'm not going to say that any of them are wrong. We just don't know because we haven't the mathematics to describe such a state of our system.
Our critics who would say, well, we don't need God because, whatever created the universe, you have to ask what created that. I said, well, God's eternal. He has no beginning. So, well, the universe is eternal. I'd say it can't be because of entropy. The universe is an energy system that's winding down. God isn't. God's eternal. The universe is not eternal. It can't be because it's suffering the effects of entropy.
Awesome. And when you were saying earlier that if you were to look up and able to see radiation, would that be similar to like the aurora borealis? Would people be able to see that everywhere? Because that's radiation, right? Or
Yeah, it would look different than that. The aurora tend to be concentrated. The aurora are beautiful. I don't know if I've seen them 3 or 4 times in my life. They rarely
I
get
have
down this
not.
far. But
I've
occasionally
actually
they do.
never seen
And they look like
the aurora
ribbons,
borealis.
And they move and everything.
It's kind of
With
shameful,
the
I
cosmic
know.
microwave background, it would be almost uniform. It would be kind of the same everywhere, the same color, because it's the same temperature everywhere. So, but it would be something that, if we could see microwaves, you could see it anywhere on Earth at night. You could look up, the sky would be glowing faintly with these microwaves. And it used to be back when we had the old televisions that got signals over the air that were not digital. And if you turn to a station that doesn't exist and you get all this static on your screen, a small fraction of that is the cosmic microwave background. Interestingly, your old television pick it up.
That's cool. That's incredible. I heard ants in a microwave do the same thing. They can actually see the radiation and they move away from it.
What's that?
I heard that ants, when they're placed inside of a microwave, can dodge the radiation. They can actually see it.
I don't know if that's true. I need to look that up.
So they can.
I haven't heard that, but that's interesting.
Yeah. But the next question was, what are some of the major problems with the Big Bang Theory? Because I'm sure you hear about it.
Yeah, the Big Bang, it's not really much of a theory. I guess you could call it a model because it doesn't really...
Well, it's both a theory and a model. So yeah, it's both. Models can be hypothetical or theoretical. And in the case of the Big Bang Theory, which is actually referred to today as the Lambda CDM model, is a theoretical model.
Really make testable predictions about...
By the way, ants don't dodge radiation. Or at least microwave radiation. They're too small to be affected by it. So Raw Matt doesn't know what the fuck he's talking about. But David Neff can attest to that because he rarely ever knows what the fuck he's talking about.
The universe, at least that have been specific and successful. Some people think that the Big Bang predicted the cosmic microwave background.
It definitely did. George Lemaitre, I believe it was, predicted that when he formed his model that there should be some form of radiation and that it should be between 1 and 50 degrees Kelvin. It's 2.73 degrees Kelvin. It's a very large range that George Lemaitre originally predicted, but it did fall within that range. He predicted it, and we found out that it's true. That is corroboration for the model.
I'll sort of grant that, but it wasn't a very specific prediction because the temperature that it predicted went from 1 degree Kelvin to 50 degree Kelvins, and the true answer of 3 Kelvins is in the right ballpark, but there was, it's like predicting that something will happen tomorrow, and then something happens tomorrow, and you say, see, that's evidence for my...
No. It's more like predicting that something will happen between 12 o'clock p.m. and 6 o'clock p.m. tomorrow, and then saying that something very, very important and pivotal in your life will happen sometime between 12 p.m. and 6 p.m. tomorrow. And then it does. You have a range. You're predicting something significant within that range, and then it happens. That's what it's like predicting. He is purposefully oversimplifying that particular prediction to downplay the efficacy and the accuracy of the Big Bang model, which, as I said earlier, is now known as the Lambda CDM model. Lambda, the Greek letter lambda, which represents dark energy, which is accelerating the expansion of spacetime, and CDM, which stands for cold, dark matter. So what this is the Big Bang model that has been modified to incorporate both dark matter and dark energy into it, because they are well observed aspects of reality, despite the fact that we do not fully understand what they are.
Hypothesis, maybe not so much. It doesn't make specific testable predictions that have been vindicated. And in fact, it predicted variation.
What did he? Hold on. Whoa. What did he just say? What did he just say?
Evidence for my hypothesis, maybe not so much. It doesn't make specific testable predictions that have been vindicated.
Yes, it does. The cosmic microwave background is one of them. The abundance of hydrogen in the early universe is another. The expansion of spacetime is another. All of these came after Georges Lemaitre proposed the Big Bang model. It's worth mentioning that Georges Lemaitre was a Catholic priest. He was a Catholic priest, and he predicted this model. He predicted that there should be an abundance of radiation permeating the whole of spacetime between 150 degrees Kelvin as a result of matter or photons decoupling from matter at some point after this event. He predicted that spacetime should be expanding because of this event, and he predicted that because of what is now known as Big Bang nucleosynthesis, that hydrogen should be the most abundant element of the universe. Literally, all three of those predictions were confirmed later. 1929, I believe, is when Edwin Hubble observed the expansion of spacetime. I could not tell you when we observed the abundance of hydrogen, but I believe it was 1964 or 1965 that we observed the cosmic microwave background radiation. Literally every prediction that the Big Bang has made has been verified. So when he says that there's no novel testable predictions that it makes, he's fucking lying to you. It's not that he's just wrong. He knows that's wrong, and he's saying it anyway because of the audience that he's speaking to. He's a fucking liar.
And in fact, it predicted variations in the cosmic microwave background that are orders of magnitude larger than what we actually see. So it didn't even predict the right kind of microwave background. So it doesn't make good, successful predictions. It's remarkably complicated in terms of all the band-aids they've had to add to it to get it to be consistent, and at least somewhat with the observable universe, like inflation. If you've heard of inflationary Big Bang, that's a patch to try and explain why we don't have monopoles and why the universe has a sort of what we call a flat topology to it. But the Big Bang didn't.
No, it's not a patch. The inflationary epoch of reality most likely happened. It meets literally, as Mad Max, John Mad Max would say, literally every last checkbox that you would need for a theory. The only one that it doesn't meet is being experimentally or observationally confirmed. And what it does is it predicted that the universe should be flat, geometrically flat, that magnetic monopoles would have been so far separated because of this event that they would have decayed before we could observe them. It explains the horizon problem by taking the universe and inflating it on numerous orders of magnitude so that all points of the universe look the same. It predicts the homogeneity and the isotropy of the universe, and it predicts the difference between the small-scale structure of reality and the large-scale structure of reality. All of these things are explained by inflationary theory. He's just wrong. He knows this. I know that he knows this. He's a fucking Ph.D. There's no way he doesn't know this. I am charitable enough to grant that he is not this incompetent in his own field. What I am not charitable enough to grant is that he's being honest. He's fucking lying, and he knows it.
Predict any of those things. So it doesn't make. It's not a good theory at all. It's at best a hypothesis. And in terms of problems, it's got all kinds of problems with it. The one that I like to mention, just because it's easy to understand, it's called the baryon asymmetry problem, or the baryon number problem. And basically, the way you remember this...
The baryon asymmetry problem has nothing to do with inflationary theory. The baryon asymmetry problem, for those who don't know, asks us why is there way more matter than there is antimatter in our universe. They should have been created in equal amounts at the Big Bang. But there's way more matter than there is antimatter. Something happened that allowed matter to dominate. We are quite certain. Why the fuck is that? We are quite certain that we have a viable explanation for why that is, and it has to do with neutrino oscillation. There are three flavors or types of neutrinos: the electron neutrino, the mu neutrino, and the tau neutrino. These three flavors of neutrinos can oscillate between each other. So an electron neutrino can become a tau neutrino and go back to an electron neutrino and back to a tau neutrino and then become a mu neutrino and then go to a tau neutrino and then back to an electron neutrino and then to a tau neutrino. And because of the way that both neutrinos and antineutrinos oscillate between their flavors, this had some effect on the production, or rather the annihilation, of matter versus antimatter, which allowed matter to dominate. This has not been experimentally or observationally confirmed, but it fits well with the math, and it is entirely viable. So the baryon asymmetry problem, while it is still technically a problem, has a viable, workable solution to it that we are working on trying to verify.
As you ask the question, where's the antimatter? We can make matter on Earth from energy. We can't make matter from nothing. Only God can do that. But we can take energy from collisions of particles at extremely high speeds, close to the speed of light in particle accelerators. And from that energy, we can create new particles. But every time you do that, you also get an antiparticle. So if you make an electron, you'll also make a positron, an anti-electron, which is the same as electron, but the charges of the particles are reversed. And so according to the Big Bang, the entire universe was originally energy, and then as it cooled, it became some of that energy became matter. But the problem is, according to everything we know about physics, you should get an exactly equal amount of antimatter. But when we look out into the universe, we find it's essentially matter only. There's only trace amounts of antimatter anywhere in the universe, and they're always produced locally anyway and almost immediately destroyed, because when matter and antimatter touch, they tend to annihilate each other and release energy, especially in the form of photons. But so the fact that our universe is matter only it indicates that it was created not by a natural process, but by a supernatural process, because every natural process that converts energy...
Yeah, it's way more likely that magic did it than that natural processes that may be as of yet unknown did it. That makes sense, because we've observed magic so often, but we've never observed natural things doing stuff.
And the matter also produces an equal amount of antimatter. And that problem has not been solved in the secular worldview. I mean, there are proposals for it. The latest idea is that, well, every now and then, one time out of a quintillion, when energy becomes matter, there's no antimatter produced. It's matter only. So but that hasn't been observed. That's just a rescuing device. It's not something that has experimental support. So that's one example. There are many others. There's the flatness problem and the monopole problem, and inflation attempts to solve at least some of those, but it doesn't solve all of them.
It doesn't attempt to solve them, it does solve them, and yes, it literally solves all of these problems. That's why it's widely accepted by the vast majority of cosmologists, because it fits neatly into the mathematical framework we currently have without practically any modification to it, and explains numerous problems that would otherwise continue to go unexplained. Like I said, it meets all of the merits of a theory, of a theoretical framework, other than that it has been experimentally or observationally confirmed. That's literally the only thing it doesn't have.
Dr. Lisle, you're touching on all the best points here. I read about the antimatter problem. I believe it was in your Taking Back Astronomy book. So great answer there. And you also mentioned inflation. Is this the rescue device essentially for what's known as the horizon problem?
That's right. The horizon problem is a light travel time problem that the secular Big Bang, as it originally was proposed, had. And basically the problem is these microwaves, which secularists assume are the leftover radiation from the Big Bang. Well, microwaves, the frequency of those microwaves tells you something about the temperature of their source. And as I mentioned earlier, that microwave background is very uniform. What that means is the source temperature of everything in the universe was originally identical, or very nearly so. The fluctuations are very tiny. And yet, in the Big Bang model, when the universe is supposed to have popped into existence, there's a singularity where all of space is contained in a point, and then it rapidly...
I actually want to provide a correction here. Singularities are mathematical objects that aren't expected to actually exist in reality. They're what happens when the limits defining the structure of space-time tend toward infinity. Singularities are not actually real things in reality. What they are mark points that essentially tell us that, hey, past this point, your math doesn't work. The universe does not actually start in a singularity. We don't know how the universe starts or if it even really has a start to begin with. So I did want to add that little bit of clarification.
It expands out like a balloon. The surface of the balloon represents the 3 dimensions of our space. And there should be hot spots and cold spots. That's just due to the Heisenberg uncertainty principle. You have to have, because of the small scale, you'd have to have places that are hot, places that have a lot of energy, places that are cool, places that have less energy. The universe rapidly expands out, carrying the hot spots and cold spots far away from each other. Wait a minute, they're all lukewarm now. Okay, all those temperatures have evened out, and yet there hasn't been enough time for light travel and therefore energy to travel from the hot spot to the cold spot to even out those temperatures. Right? I mean, if the hot and cold were in contact with each other, they would eventually come to the same temperature because heat tends to go from hot to cold. That's the second law of thermodynamics. So you put your ice cube in your hot coffee, eventually you'll end up with, lukewarm coffee. They come to the same temperature. But they have to be in contact. They have to be able to exchange energy. And there hasn't been enough time, even if you give them the 13.8 billion years, there hasn't been enough time for light to travel from that hot spot to that cold spot.
If inflation happened, we don't need that time. It stretched those parts away from each other so rapidly that they were capable of regionally or locally uniforming their temperature. It's exactly what inflationary theory tells us.
Because they could be on opposite sides of the visible universe. And so the inflation is an attempt to solve that problem, along with the flatness problem and perhaps the monopole problem. But the idea of inflation is that the universe started expanding at what we'll call the slow rate, although it's actually very fast. And then it suddenly ballooned out at a much faster rate. And then that inflation phase, that's the inflation phase. And then that switched off and it went back to the slow rate again. And so the idea is that the hot spots and cold spots could have evened each other out right before this inflation phase pushed them far apart. And I'll grant that could reduce, maybe even solve the horizon problem, but it introduces other problems.
It does, and no, it introduces no other problems.
Problems of its own, such as what would cause the universe to suddenly expand at a much greater rate. Now, there are hypotheses as well, some kind of symmetry breaking in the laws of physics. And then you got to ask, what would it cause it? How would it stop everywhere? And how would it know to stop everywhere at the same time? That is a huge problem because
that's not a problem at all. Inflationary theory tells us that under the grand unified theory or the unified field theory, all fundamental forces would have been combined into one field with one particle of that field. This would have been called the inflaton field. The particle would have been called the inflaton. And what happened is as the universe expanded, this field, the particles of it started to decay into the typical matter particles that we see today. What this would have done is created an extraordinarily powerful anti-gravitational force that would have driven space-time apart uniformly, allowing it to undergo what we now call inflation. Once this field was done decaying, inflation would have stopped. So yes, we have mechanisms for how this occurred and how it stopped. Again, Dr. Lisle is just doing exactly that, lying through his weaselly fucking teeth.
There are still small temperature differences. Even today, there are small temperature differences, and so with some kind of symmetry breaking, you would think it would turn off different places at different times, but it didn't. You have kind of a uniform universe, and so that's called the graceful exit problem. So the horizon problem, inflation, an attempt to solve the horizon problem, and then the graceful exit problem is a problem.
Which isn't a problem at all. I've never heard of that. I've read a lot of literature on this. I've literally never heard of a graceful exit problem. It's not. It just doesn't exist.
With inflation. And some secularists reject inflation entirely because they realize it has its own issues. They proposed alternative solutions.
A very, 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 very small amount of cosmologists reject it. An extraordinarily small amount of them reject it. The reason that some of them reject it is because they don't think it happened. None of them, literally none of them has been capable of producing as viable and as explanatory a model to explain what we see in our current universe as inflation, as the inflationary model does. Paul Steinhardt, who's one alongside Alan Guth, who's one of the ones that helped develop the inflationary model, is one of the ones that denies it. He has even admitted, we don't have a better model to explain this. We just don't think it was inflation.
To the horizon problem, but I think inflation is still the most commonly accepted secular solution to a problem. But as I said, it's got problems of its own.
Wow, great answer. So they say we have a light travel time problem.
I'm going to run to the bathroom again. Sorry, I have to. But I'm going to leave this playing so you guys aren't bored. I will be back in roughly 30 to 45 seconds. Hold tight. Don't go anywhere.
In fact, they're the ones with the massive light travel time problem. And then based on what you said, in order for them to solve that problem, it turns into a ripple effect of other hard-to-solve problems. And you pointed out that some authorities on the subject even reject inflationary theory for that reason.
Yep. And I'll point out too, just in case anybody's wondering, that the anisotropic synchrony convention solved their horizon problem. The answer is no, because they need to get the speed of light both ways to be much faster than it really is. Because it's not just the hot spots here that have to get information, have to dump energy to the cold spot there, but it's also a hot spot here that has to dump energy to the cold spot over there. So it has to be faster in both ways. And the anisotropic synchrony convention, you can only have light instant in one particular direction relative to an observer. Now, it could be the incoming direction, regardless of what that is.
Right.
So north to south if it's this way, and south to north if it's that way. But you can't have it then going out in that same direction. It'd be also instant. So synchrony conventions will not solve the horizon problem. But we have an answer for our starlight problem that is consistent with known physics, and the seculars really don't.
Wow, that's awesome. Great point there. And a couple questions came in pertaining to that answer. Let me see here. Guys, great questions in the chat. Very lively chat. I'll never be able to get to all these, so let me at least pick a couple out. Super chat here from Jamie Russell. Thank you, Jamie. Can you explain how the universe doesn't have a center or could be infinite if we started as a point in Big Bang cosmology?
Yeah, entertaining for the sake of argument, the Big Bang idea that the universe started from a point which expands like a balloon. The surface of the balloon, which is two-dimensional, is supposed to represent the three-dimensional nature of our universe. You can think about our universe, if you wish, you can think about it being wrapped around a fourth dimension that we can't perceive. And so just as the surface, there's no one point on the surface of a balloon that is the center, right? And so, there's no unique center. I mean, every ant's walking along the balloon, every one of them can say, I'm in the center, but so could every other ant. And they're actually on the surface of an expanding two-dimensional structure, whereas we apparently live in a three-dimensional structure that's expanding. If you want to think of it as being wrapped around a fourth dimension, you can do that, although it's not really necessary mathematically for that to be the case. So, even though I don't believe the universe started from a point, I do believe it's expanding. I think there's good evidence for that. And the balloon analogy, I think that works for a creationist universe too. It's just God created our balloon with size, and then he's blown it up a little bit since then. Our balloon was never a point. And if that's the case, then there may be no unique center to our universe. Or there could be a center. We don't really know. It could be that the galaxies end at some point. It could be that there are a finite number of galaxies in the universe, and then at some point there aren't any, and there's just space beyond that. It could be the case. It could be that our universe wraps around on itself. We don't really know. But any of those are possibilities.
Right, great answer. Yeah,
So I'd like to provide my own answer, but before that, while I was in the bathroom, I'm pretty sure it was the part where he talks about that, well, light from this area can't get to this area, and light from this area can't get to this area, and that's why the horizon problem hasn't been solved. But on his own model, light travels instantaneously. So light from here would hit this point instantaneously, and light from here would hit this point instantaneously. So on his model, there shouldn't even be a horizon problem. How the fuck does he not know this? This is insane. Also, the universe doesn't have a center. Kind of for what he explained. It's just what he explained is a little bit more simplistic. But it doesn't have a center because its expansion is a geometric expansion of its scale. So just like if you were to create a rubber band, you know what? Give me just a second here. We're going to do a fun little experiment. See what we can get here. Give me a second here. Draw some lines. It might take just a couple seconds, but bear with me. By the way, if you're watching this and you aren't already subscribed to my channel, please consider subscribing. I would really appreciate it. I'm trying to grow the Lion's Den into somewhat of a community, so I would very much appreciate if you would contribute to that. We will be doing videos and live streams like this quite frequently, as long as the creationists keep giving us content to respond to, which I'm sure we all agree they will, because they don't ever stop. Because they're a bunch of fucking idiots who just don't know when to stop. Either that, or they have to pander to a particular audience. Alrighty, I think we've got it. So, what we have here is a rubber band. You can see lines on it. Now, if I stretch the rubber band, you might notice something. The further apart any two lines are on this rubber band, faster they move away from each other. So if I center it on any one particular line and stretch it, it looks like that's the center. You might think that this line is the center of the rubber band. I mean, technically it would be, because there's a defined limit to this rubber band. But if you went from any of these lines, you looked at this rubber band stretching, it would look like it's stretching away from your particular line. That's exactly what the universe does. You could measure the universe's expansion from any point within it, and it's going to look like you're measuring it from the center. That's because its expansion is a geometric expansion of its scale. That's why the universe doesn't have a center. There is no center. It just doesn't exist. The universe doesn't have an edge either, I might add.
Like I said before, this is such fascinating stuff, and let me see here. I'll grab this one. I'll definitely get the super chats, guys. So, Jungle Jargon for $5 asks, could the vacuum of space be causing the redshift?
In a sense, that's actually the most common view, actually, because the idea is, when people think of redshift, they think of the Doppler effect a lot of times. Just the way the sound of a car's horn changes as it goes past you, it drops. Light will do that too. Light will shift toward the red. Much harder to see with light because, well, for two reasons. For one, speed's just unimaginable. Light is so much faster than anything else we experience. And secondly, our eyes are not analyzers. Our eyes are synthesizers. Our eyes combine wavelengths into a color experience, where our ears don't do that. Our ears can separate sounds into different frequencies. So if I hit two notes on a piano, you'll hear two notes. But if I shine two colors in a circle, you'll see one color. You'll see that combined. So there's a difference there. But with spectroscopes, you can measure the shift of the spectral lines in these galaxies. And the farther away galaxies are, the more redshifted they are. And the initial explanation for that was, well, they're moving away from each other. But probably a better explanation is that you can think of them as being at rest on a universe that's actually expanding. And as the light travels through that expanding fabric of space, it gets stretched out. And so it's in the most popular view, which I think is probably right, that the redshifts are caused not by Doppler shifts, but by expansion of the universe, at least on a cosmic scale. The reason that distant galaxies are redshifted is because of the stretching of the fabric of space as light travels through them. And so, the vacuum space probably is what's causing a lot of the redshifts, although motion will do it too.
Awesome. I appreciate that answer, Dr. Lisle. Thanks for the super chat, Jungle Jargon. A lot of people enjoying this. Thanks for the conversation. Very informative. So I've got Dr. Lisle's website in the description box, so please check that out for more information on this. This has been awesome, Dr. Lisle. My next question would be, I watched an interview with you not too long ago on craters, and I think it would be a good question and answer for my audience to hear. So I would ask, how best do we explain then craters according to the young biblical creation model?
Well, there's different types of craters. There's volcanic craters, there's impact craters. I presume you're thinking of the craters like on the moon. The interesting thing is, 100 years ago, the craters on the moon, everybody thought those were volcanic in origin. And so the idea that they're impact craters is recent, but now most scientists believe that the craters on the moon, or the bulk of them, caused by something hitting the moon, boom, and that creates it excavates the material there, and we can simulate that. Well, you can simulate that on the beach. You take a rock and throw it in the sand, and you get a little crater there. So we think that the craters on the moon formed that way. The question is when, and when did this happen? When did all these craters occur? And I don't think there's a creationist consensus on that issue. There are different creationists have different views on it. My best guess would be that during the creation week, that when God created the planets, when he created the stars on day 4 of the creation week, that he may have used process to do that. That he might have made the material for the stars on day 1 and then collected it on day 4 and compressed it into planets and the moon, for example. And so the last bit of material that's being collected to make the moon, that could be...
If God did all this stuff, how did he do it? What's the mechanism at work for how he did this? By the way, I have a really good friend, Speed of Sound of Gravity, in the chat. If you're not subscribed to his channel, you definitely should be. I don't know what the fuck you're doing with your life if you're not subscribed to him.
Responsible for those craters. We don't really know. All we know is that all the solid bodies of our solar system have craters on their surface. Most of them have quite a lot of craters, with the exception being Earth and Jupiter's moon Io, or Io. The reason Io doesn't have impact craters is because it's so volcanically active. It's been completely resurfaced by the material that's being expelled from its own volcanoes. And Earth, I suspect, doesn't have any craters. The secularists say because of plate tectonics, they've erased it. But I would say it's because it was created by a different process. Earth's made on day 1, whereas all the other objects are made on day 4. So God may have used a different process. Earth was originally water. The other worlds, we don't know that for the other worlds. They might have been, but we don't know that. So that's a possibility, but we don't really know when the craters happen. But there's good evidence that they're impact craters. The shape of them is consistent with what happens when debris hits material at very high speed.
Awesome. We got another critic question here for you. They feel that this one actually defeats biblical creation, as we know it won't.
Ooh,
but multiple
juicy.
meteorites, moon rocks, and Martian rocks dated on location all use a consistent age of 4.6 billion years, plus or minus. This is true across a variety of locations, across a variety of different dating methods.
We don't.
How would you explain this?
We don't have any access for sure to anything from Mars by which we could date it. It's thought that some of the rocks that we collect on Earth that are meteorites may have originally been from Mars. I'm a little skeptical of that. We certainly don't know that's the case. We do have rocks from the moon, and those have been dated using the uranium-lead, I believe, method, and perhaps others. And yeah, you do get ages of 4.5 billion years, which you don't get for Earth rocks. Interestingly, you don't get quite as old ages for Earth rocks. So, but the secular thinking is that
I do want to apologize. A lot of the frames are dropping. Like it just did there. I don't believe that was happening early on in the video. I don't know why that's happening. That's why I keep pausing when I speak, because I'm watching the kilobytes per second, and it seems to be fluctuating pretty heavy. I'm probably not going to go too much longer, because we're almost at the 2-hour mark, and we're through the bulk of the video that I did want to address, but let's continue. Hopefully it doesn't keep acting up the way that it is.
Earth's been reworked by plate tectonics, so you don't have original Earth rocks. They've all been reworked multiple times. What's the explanation for that? Well, we think that there's very compelling evidence that the rate at which radioactive decay has happened in the past has been accelerated, and that would account for why there tends to be a convergence on a particular age for rocks that are not Earth rocks. For Earth rocks, you get inconsistent ages. You can take an Earth rock and date it using one method and then date it using another method, and you get different answers.
Well, of course you're going to get different answers, because different dating methods are only viable for certain periods of time. I mean, I believe that's... I thought that was well known. Javers asks, how's your heat? My laptop actually doesn't seem to be too hot. The camera's going to go a little awry as I feel underneath it, but I'll probably start wrapping up once we hit the 2-hour mark. I think that's pretty good for a first-time stream. Like I said, we have hit the bulk of this video that I did want to address, so... Sorry about that, it just keeps happening. I don't believe this was happening early in the video, but yeah, we'll probably go. We've got another 7 minutes. I think everybody can bear through it. I don't know what James Downard says. The sound has been pretty much smooth from his end, so I don't know if it's the sound that's going out or if it's just the video. But hopefully it's just a video and you guys can still hear me. But I keep pausing when it drops very low when it goes into the red, just because I don't know if it affects my sound or not. But yeah, we'll go for a little bit longer, and then I'll probably start wrapping things up.
And this has been well documented. John Woodmarapi's book, The Mythology of Modern Dating Methods, documents published dates. These are ones that have been peer-reviewed. They're published in the peer-reviewed literature, to say nothing of the dates that were inconsistent and therefore never published. I mean, think about that. Think you're a secularist and you date a rock and it gets you an A.
Well, the problem is, if we date a rock and it's inconsistent with what we've already demonstrated to be the case, of course they're not going to publish it. There's obviously something going wrong with their methodologies, and they don't want to publish it because they're actually honest scientists who don't feel like publishing bunk science. I don't feel that you would probably know much about that, Dr. Lisle, would you?
Age that's way off what is expected to be for that formation. Probably don't publish it. You say, well, so obviously something went wrong there. And so the fact that you have inconsistent data even within the literature that was published suggests that there's a far greater number of inconsistencies that have not been published. The Rate Research Project, too, in their book, they also documented, there's a chapter on the discordant date. So it's not as consistent as you've been led to believe. Now, I do think it's a little more consistent for moon rocks because they haven't been reworked. There was no worldwide flood on the moon. And so whatever process God used to make the moon apparently was pretty uniform. And so even though the decay rates have been accelerated, there's good evidence for that.
By the way, just in case those don't know, the moon was created when a Mars-sized object struck the Earth about 4 billion years ago, 4.2 billion years ago maybe. And what happened is it reliquefied the surface of the Earth, but at the same time, it took part of the Earth with it. That object didn't actually get very far away from the Earth after it collided with it. You can still see it in the night sky oftentimes today. We call it the moon.
The rate research on that presumably happened at a uniform rate, so that's why you get some degree of consistency with moon rocks, but very little consistency with Earth rocks.
Well, what just happened?
There probably is some
I have
kind
no
of
idea what just happened. There we go.
Enhancement of the decay rates.
There we go.
For example,
Just a
here's
little
something.
glitch. It happens every now and then.
When they went to the moon and they got one of the first
I think my
rocks,
finger
they
hit
brought
the
it back.
scroll
I forget
button
the
there.
exact number, what they identified it as. They didn't actually call it a specific rock. They gave it a number. Here it is. Lunar sample 14321. It dated at 4 billion years old, but when they tested it, it was actually a piece of driftwood from Earth. But the oldest tree dated is 350 million years ago on Earth. So how could that even be a thing? I'm just curious if you ever heard about that, or
I haven't heard about that specific one. I have heard of examples of, for example, wood that's embedded inside rock. You know, volcano will come, uproot trees, lava will flow over it.
Petrified
So you
wood,
have
yeah.
wood embedded in rock. The rock dates to millions of years, and the wood dates to thousands of years. So that's a problem. And in case people are wondering, when you date a rock, it's supposed to tell you when the rock hardened, because before that everything's liquid. The minerals can move in and out. But when it solidifies, then that's supposed to trap the parent and daughter elements. So the only way you get daughter elements is by the conversion of parent elements. And yet you get wild inconsistencies. So inconsistencies in radiometric dating is not new. It's well known. And we've taken rocks from Mount St. Helens, brand new rocks, sent them into secular labs to have them dated.
Alrighty, well, we're starting to get into more radiometric dating. There's still a good chunk of this video left, at least a good half an hour. But I think it's a good time to wrap up. I think we've hit the bulk majority of what I wanted to address, which was more of the astrophysics arguments he was making. I think I've made my point. Like I said at the beginning of this video, tell me if you think that he knows what he's saying is false and he's saying it anyway and he's just a fucking liar, a weaselly little liar, or if you think that Dr. Lisle here is just that incompetent in its own field. So to end, like I said earlier, I noticed that the frame started to drop there. I don't know if anybody heard me, but I have a good friend, Speed of Sound of Gravity. If you're not subscribed to his channel, I don't know what you're doing with his life, because he produces a lot of content. Quite frankly, he produces more than I do. But if you're not subscribed to my channel, please do consider hitting that subscribe button and also ringing that bell so that you can be notified of any new content that is to come. I have a lot more content like this to be produced. I'm going to be doing live streams more often now that I know that they work and that they work well. So yeah, I had a lot of fun here. Hopefully everybody learned something new. Hopefully everybody learned that We shouldn't trust somebody just because they have a degree in a field. We need to pay attention to the words that they're speaking and fact check them with the consensus of the field, as well as the literature that's published in the field, because I think that that's a very relevant point to make. I think that just believing somebody at their word just because they're a professional isn't really the best way to go about it. You need to cross-examine what they're saying against what other people in the field are saying, against what the published literature in the field is saying. And I think that utilizing those methods, you'll come to a reasonable answer. So I do hope that you all had a really, really good time. Hopefully you guys are subscribed, and if you're not, hopefully you do consider subscribing, like I said earlier, because I would really enjoy growing this community that we have going on here, the Lion's Den as I'm calling it. And with that, I leave you with the phrase, per causam nos perfectum, which is Latin for through reason progress. Well, take care now.